Graphing inequalities is our section for today, number 8.6. The graph of a linear inequality is a region on a coordinate plane whose edge is a line. Okay? And the line mentioned above, so this line up above, is called the boundary line. So I have it in a graphic example for you. Okay? So we have the line graphed, and then this part that's the shaded part, that's your solution region. Or here, this could be your boundary line, and then that could be your solution region. So how to graph an inequality? So first you're going to graph the boundary line first. This is what we already know how to do. All right, you're just going to graph the line. Decide whether to use a solid or a dashed line. If you notice on the two previous examples, one had a solid line, one had a dashed line. Okay, you're going to use a solid boundary line if it's going to be less than or equal to or greater than or equal to. Or you're going to use a dashed boundary line if it's less than or greater than. Okay, it's pretty straightforward. Then you need to pick a point that's not on the line. Evaluate the inequality for values of the coordinates of this point. Okay, so we're going to plug it in, and if the inequality is true, then we're going to shade the region on the same side of the line. If it's false, we're going to shade on the other side. Okay, so let us put this into practice. All right, so first we're going to graph this line. First step is to just graph the line. So I start at 4. And I go up 1 over 2, just like we've been practicing. Okay? Then we said if there's no underline, then it's going to be a dashed line. Because that means it doesn't include the line. It's just our boundary. And then to decide which side to shade, we have to test a point. I'm going to tell you, you can have the least amount of math if you do the origin. Okay? So if I test the origin, x is 0 and y is 0. So if I go up here, half times 0 plus 4, and then put 0 in for y. Well, half of 0 is 0. 0 plus 4 is 4. Is 0 greater than 4? No. Okay, so then you go back to your steps, and you see that if it's false, I'm not going to shade the side of the line where I tested my point. I'm going to shade the other side. So then I get my shader. Whoops, wrong one. And we shade this side of the line. So it's saying for y is greater than a half x plus 4, any point on this side of the line would be true, okay, for this inequality. So that's why we're just going to shade all the points on that side. All right, let's try another one. So this one starts at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go down 5 over 1. And we don't have an underline, so again, we're going to have a dashed line. Okay. And then we have to test to see which side we're going to shade. So again, let's test the origin, because it's not on the line. We can do that. So if y is 0, x is also 0. 5 times 0 is 0, and 9 minus 5 is 4. Is 0 greater than 4? Nope. So I'm going to shade the other side of the line. Okay? And that's all there is to it. So let's try another one. All right, we got x is less than negative 3. Okay, if you remember, if it's x and a number, that means it's a vertical line. So we're going to draw a vertical line at negative 3, and it's going to be dashed, because there's no underline. And if x is less than 3, so if I test the origin, x is 0, I don't have a y. So is 0 less than negative 3? Nope. So we're going to shade the other side. So far, all the ones we've tested are false. So it's anything on this side of the line. Okay, here we have one in standard form. So we're either going to have to do the method 2, the cover-up method, or you're going to need to solve it for y. Okay, now be careful on this one. When you divide by a negative, you have to flip the inequality. So now it's negative 6 and it's plus 3/4 x. So I'm going to start at negative 6. and then up 3 over 4. Okay, no underline, so I'm going to make it dashed. And let's see, if we want to have it shaded, we got to test a point. If we test the origin again, 3 times 0 minus 4 times 0, is that greater than 24? Well, this would be 0 minus 0. Is 0 greater than 24? Nope. So I'm going to shade the other side. Okay. Another one in standard form. Okay, I'm not going to switch the sign this side because I divided by a positive, so it's going to remain greater than or equal to. And this is negative 2 minus a third x. So I'm going to start at negative 2 and go down 1 over 3, or up 1, back 3. And this time I do have an underline, so I'm going to make that a solid line. And then let's test the origin. If I test the origin, I get 0 plus 3 times 0. Is that greater than or equal to negative 6? 0 plus 0 is 0. Is that greater than or equal to negative 6? It is. So that means I'm going to shade the side of the line that includes my origin. Oops, wrong button. Hang on. So it's going to be this side this time, over the point I tested. All right, so we're going to reverse on this one. We're going to write the inequality that fits the graph. So first thing we have to do is write the equation of the line. All right, so let's just start with y equals, let's see, my intercept is negative 1. My slope is up 1, 2, 3 over 1. Okay, now I have to decide, well, let's see. It's going to have a solid. So we know we're going to have that underline. We just have to decide if it's less than or equal to or greater than or equal to. I can still test the origin, okay, because it's not on my line. It's close, but it's not on my line, so I'm good. So let's test 0, 0, and we're just trying to decide which way this is going to go. I'm just going to use equals for now, even though it's really not. Okay, so 0 equals negative 1 plus 0, so 0 and negative 1. All right, what symbol is going to have to go in here to make it true? 0 is greater than negative 1, correct? Okay, so that's the symbol I want here, is greater than, and then it's also going to be greater than or equal to because we have a solid line. Okay, and then let's check it. Starts at negative 1, goes up 3 over 1. It's a solid line. We tested the origin, and 0 is greater than negative 1, so we're good.